So I'd be like in charge of the social media.
We'll just wait another minute. People are still trickling in, so. All right, I'm going to go ahead and get started. Can everybody hear me okay? Somebody shout in the chat if you can hear me.
You sound great, Tom.
Hear me? Awesome. Great. Awesome. Okay. All right. So thanks everybody for coming. For those who don't know me, oh, hold on. I'm just gonna go and make sure people are muted. Okay, I'll try to pounce on that. We'll see. All right, so for those who don't know me, my name is Tom Williams. I'm an assistant professor in the computer science department. You are at the computer science department seminar. I realize it's easy to lose track of these things sometimes when you're not actually in a room and you can't see who else is there. But that is where you are. Hopefully that's where you're supposed to be. I direct the Mirror Lab, the Minds Interactive Robotics Research Lab. And today I'm going to be talking about secret agents, the real and imagined inner lives of interactive robots, by which I really mean everything that the Mirror Lab has worked on, almost everything, a lot of the stuff that the Mirror Lab has worked on over the past 4 years. In order to start, we need to talk about why I'm titling this talk Secret Agents, what I mean when I say agents. So an agent, when we're outside the context of, a spy movie, and in the context of robotics, is something, if you believe certain philosophers of robotics, something that is autonomous, that is, it can change its state without stimuli. It's something that's interactive, that is, it can change its state in response to stimuli, and to human-robot interaction researchers like me, that often means changing state in response to stimuli from humans. And adaptive, that is, has the ability to change the internal transition rules that govern those state changes. Or really, because each of these is something that needs to be observed for it to hold, an agent is really something that at least appears to change state without stimuli, appears to change state in response to stimuli, and appears to change state transition rules. And the reason why this appearance is critical is because it means that something that doesn't seem to be an agent due to it being really simple or due to being puppeteered for us as scientists or programmers or designers may still be an agent to naive users who see the robot and say, yeah, that seems like it's really adapting, even if, again, behind the scenes, a programmer might look at that and say, well, technically, it's not really adaptive. So the question then is, before we can talk about why this matters, why we're talking about this concept of agency in robotics, we can start by talking about what leads people to view robots as agents in the first place. And in some cases, what causes people to view robots as agents that are interactive, for example, is the way that robots perform the sense of having a sense of self. And this is some work that we just published a couple of months ago at HRI. The idea here is that, let's say you are on the street and you are accosted by 3 robots. These robots introduce themselves as Alex and Avery and Adrian. The fact that these robots are using names and talking to you sort of seems to imply that, well, there are 3 beings in front of you, each with their own intelligence. And when you see this, you might start to form some mental models of how to understand these robots. Here, you might start to think about whether you should be trusting these robots that have accosted you on the street. And when you do so, you're going to build up different mental representations of these different robots. Moreover, you might build up different representations and establish different levels of trust, not just in Alex and Avery and Adrian, but in those sort of artificial intelligences differently from the bodies. So you might trust Alex, the brain of Alex, more than you trust the body of Alex to accomplish a particular task, for example. However, if you encounter 3 robots on the street, if you encounter 3 robots anywhere, it's pretty likely that those robots, at least today, are not 3 distinct individuals. It's more likely that they're actually networked together. It's more likely that there's just a single piece of software that is controlling this networked system. Yes, there might be some code that's running locally on each of these robots, but it's likely that they're actually just completely networked together. They're sharing information. You can really think of it as one brain with multiple bodies, which means that this picture we've drawn of having these 3 distinct individuals is sort of a lie. And it means that this system is sort of manipulating you. By having each of these different robot bodies use an individual name, sort of is pretending or performing the idea that they're distinct entities, whereas in fact, to a designer behind the scenes, the designer might look at that and say, it's all one system. Now, this notion of sort of a disconnect between how robot bodies and their identities connect with each other, being different from like traditional normal people just having one mind and one body, can be explored in a lot of different ways. So some of our collaborators from Carnegie Mellon, for example, have started to look at things like co-embodiment as well, where you have one body but multiple brains in that body, or multiple identities, so that when you're talking with that single robot body, sometimes you're talking with one entity, sometimes with another. You can think of this like having multiple voice assistants stored in your phone and sort of switching between interacting with them. And our hypothesis is, again, in this type of setting, you're going to develop different mental representations and different levels of trust in the different identities that are inhabiting that body and with the body itself. What this means is that designers, by communicating identity in different ways, can lead users to develop fundamentally different understandings of the social others that are in their environments. And in recent work, we have started to formalize a theory for how we should be thinking about robots in these distributed systems. And especially the way that we should separately be thinking about the way that people trust individual robot bodies versus the way that people trust the identities that are inhabiting those bodies. So we call this deconstructed trustee theory, because we're breaking our notion of trust in a robot down into how much you trust the body versus how much you trust the identity, as well as notions like how much you trust these bodies and identities in terms of their capabilities versus how much you trust them morally. And we'll come back to morality quite a bit later in this talk. This theory makes a number of predictions. It predicts that different levels of trust can be built and lost in body versus identity. It predicts that different robot identity performance strategies, like pretending to have sort of one mind associated with each body versus breaking that illusion of human likeness, may change how much people treat these different identities as real, coherent individuals and the amount of trust they build in them. And it suggests that different trust-building actions, like actions that build trust versus actions that destroy trust, may change the concreteness, again, of those robot identities. And we've started to collect a variety of data supporting this hypothesis. Now, I'm not going to talk about any. I'm going to try not to have any charts with in this any specific results in this paper. I'm going to try not to get too far into the depths of individual algorithms, so that we can get a sense of all the different things we're working on and how they fit together. But if you are interested in the evidence we've been collecting in terms of this work on body and identity, we have a paper at HRI this year. So why does this matter? The reason why it matters is because if people perceive robots as human-like agents with human-like senses of body and identity that are autonomous, interactive, and adaptive in the same way that people are, then they will mentally reason about robots and try to interact with those robots the same way that they try to interact with and reason about humans. So the question then is, well, how do people reason about other people? And this is what psychologists call theory of mind. You can also think of it as sort of like mind reading, trying to estimate what's going on in other people's heads. And psychologists suggest that cognition is broken down into two systems. You have fast, instinctual cognition, and you have a slow, deliberative, careful cognition. And in terms of theory of mind, the way this works is we can quickly, instinctively assess what things we think other people are aware of. And then we can slowly and deliberately reason about what we think other people think about those things in the environment. As an example, here, if we have this person in the white coat is holding this folder, he might try to reason about this other agent and say, is this other person aware of the folder I'm holding? Or even make a little bit more granularity. Are they aware of it? Are they familiar with it? Or is it actually currently activated in their mind? Or are they already focusing on it? And this is something that they should be able to do very quickly. This is a system one capability. And in our lab, what we've shown is that robots can do this as well. Robots can do this type of sort of mind reading, estimating what's on the mind of other people using simple Bayesian filtering methods. And we found that just using very simple linguistic features about how and when objects are mentioned, you can get very accurate models of what people are thinking about. This is important not just for the sake of knowing what other people are thinking about, but also for knowing how to talk about those things. So the agent in the white coat here, let's say he wants to talk about the folder.
I have a printed out copy that I'm not allowed to open. So
I'm going to mute the people who are talking. In order to figure out how to talk about this folder, he might try to reason about what the status of that information is for this other agent. If the other agent is already focusing on it, he could probably just say it. If the other agent isn't currently focusing on it, he might need to say something more complicated, like, oh, you see this folder I have in my hand? And say that instead of something really short and concise. And so similarly, in recent work, we've shown how we can automatically estimate a cognitive status and then use that for the purposes of referential choice, using this notion of, is the other person already thinking about this, to decide whether to talk about something using it or this or that, or the folder I hold in my hand. And what we've also found is that this cognitive status is the most important and informative feature for making this type of decision. The other way that this can be used then is not just for reasoning about what other people are thinking about and then deciding how to talk about it, but deciding how you can manipulate other people's cognitive status in order to change how you can talk. So let's say I'm pulling this folder and I want to talk about it, but I'm really lazy and I don't want to give a really long, complicated expression. I just want to say something like this. In order to just say this, I can make the object activated in the mind of the person I'm talking to by pointing to it. If I point to it, I'll draw their attention to it, and that'll be activated for them. So if I just say this, I can assume that they'll know what I'm talking about because I know that the object is activated for them. And in some of our very recent work, we've been looking at how robots can use gestures to sort of manipulate the cognitive status of information for people as well. And we've been looking at this, one of the really novel things about what we've been doing is looking at this in large-scale context, looking at how people gesture to things, not just when they're really close, but when they're far away. The way that, like, if I want to talk about this book, I might point to it and look at it and say this book. But if I want to talk about New York City, I probably wouldn't like gaze off camera and point very sharply and say New York City. I would just say like New York City, something like that. And what we've been doing then is allowing robots to also generate these types of gestures that are sensitive to these sort of distance and occlusion type of considerations. And what we've shown is that robots that use these visibility sensitive gestures allow participants to much more accurately identify what they're actually talking about, which is good. One note here is from the previous slide, I drew this circle in orange around the folder when I was talking about it. So this was a way of bringing your attention to the folder. And now on this slide, actually the arrow pointing to the circle. The arrow is a way of drawing your attention to the circle, which I was using to draw your attention to the folder. And this is interesting because these icons on that slide sort of served as a form of gesture as well. They are drawing your attention to something in the scene that I want you to look at. And we have figured out that you can actually do the same thing with robots as well when they are in augmented reality environments. So what we have looked at is how robots can use these augmented reality gestures, drawing, if somebody is wearing an augmented reality headset, drawing a circle or an arrow or something like that in their field of view, the same way that somebody would normally point to something. And this is really helpful for robots like the one shown in this picture who don't have arms and thus can't point. And we found that this is really effective, especially when the thing that the robot is talking about is highly ambiguous, and especially when the robot uses a lot of descriptive language with these types of gestures. More recently, we have actually used this to develop autonomous gesturing capabilities for robots, allowing robots to use these augmented reality gestures on the fly when they're talking about objects in order to help pick them out. And again, we found that this is really effective even in context where the person already has a lot of visual load. It's a very cluttered environment. They're having to look at a lot of things. These augmented reality visualizations are still really effective. Of course, these visualizations are, circles and arrows are obviously very different from the way that humans gesture. But in recent work, we've been looking at more human-like augmented reality gestures as well. We've been looking at, for example, at completely virtual arms that a robot could use to point to things. This is, and we started looking at this in conjunction with Dr. Dantum's lab, who were looking at different ways that robots could generate these types of pointing gestures. And we've used that to then enable robots to have these virtual arms that point at things. And we've been looking at when the virtual arms are effective and when these arrows are effective. And what we found is that like circling something or drawing an arrow over it is really effective at getting the person you're talking to quickly and accurately understand what you're talking about. But that's not always what we want. Sometimes we want the other person to perceive the robot as human-like or really natural or competent. And the virtual arm is much better at that, which is really important for sort of long-term interaction and team performance. Okay, so the takeaway from this section of the talk is that people perceive robots as interactive, autonomous, and adaptive, which means that robots are agents. designers can manipulate people's mental representations of those robot agents through different ways of performing a sense of self. And people expect robots to reason about their own mental states as well. And robots can estimate people's mental states and then use them to communicate in some pretty unique ways. So now that we've established that robots are agents, I want to dive in a little bit more and talk about what kind of agents robots are. The first type of agent that robots are is moral agents. And Flaherty and Sanders define moral agents as just agents that are capable of moral action, where moral action are actions that do moral benefit, moral good or moral harm to people. Robots are capable of taking actions that do harm to people. This is obvious in terms of physical harm and in human-robot interaction, for example. When we look at space robotics or search and rescue robotics, these are physically safety-critical environments. There's a lot of potential for harm. But this is also true in the sense of, if you look at elder care robots or education robots, where robots have a lot of potential for emotional harm or for other types of sort of persuasion and influence on people. Our hypothesis then is because robots are moral agents in all of these contexts, people will expect them to follow human moral standards and norms and will also pay attention to what robots do and take moral cues from them. So the reason why we think this is important is because we argue that it could lead to unintentional negative moral influence. A robot that who is given an unethical command, like, I don't know, like punch Bob, and doesn't explicitly reject that command, may unintentionally communicate that they would be willing to perform that action, even if the robot isn't actively condoning it. An example of this is clarification. If I ask you to punch Bob and you say, oh, like, do you mean like Bob Jones or Bob Jeffries? What I'm going to take away from that is that you are willing to punch somebody, you're just not sure who to punch. Even if I had said, punch Bob Jones, and you said, oh my God, how could you ask me to do that? The act of me asking for that clarification in the first place sort of communicated that I was willing to do it. The idea then is if robots do this, even if they're not willing to actually do these actions, it could mislead people about the robot's actual moral beliefs. This may influence human beliefs about what norms actually apply in a particular context, which could change what actions they themselves view as appropriate. The reason why we think this is because there's a major tenet of modern behavioral ethics that morality is dynamic. That means it changes from context to context, and it's malleable. That means it changes over time. Moreover, the philosophy of technology literature suggests that technology mediates human perceptions and actions in ethically relevant ways. What that means is technology literally changes the way we see the world. My glasses are changing how I can perceive the world, and it changes the actions that are available to us in this world. I mean, even in this context, I can gesture with my glasses. It's changing the set of actions that I view as available to me, and thus changing the way I interact with the world. If you're not convinced by that argument, well, we actually did an experiment, and we found that robots have a lot of potential moral influence. We showed people videos of robots responding to these sort of ambiguous clarification requests by asking for clarification. What we found is that people subsequently not only believed that the robot would be willing to perform the action it was asking about, but they were more likely to also rate that action as acceptable for the robot to perform. So the robot, by asking for clarification, was changing what they viewed as acceptable for the robot to do in that context. That's not great. So we have been doing some computational work where we've been developing algorithms to allow robots to not do this. So if a robot gets an ambiguous command like punch Bob, before actually asking for clarification, it'll consider all the different ways it could interpret that command, simulate all of them, and see what would happen if it did them, and then decide whether it should be asking for clarification versus just saying, no, I can't punch anyone. Of course, our goal shouldn't just be avoiding miscommunication. When a robot receives an immoral command, regardless of whether or not it's ambiguous, it should say no, it should push back on that command. In recent work, we've been working with the DIA lab and the Human-Centered Robotics lab to allow robots to automatically identify when commands are problematic and reject them. Moreover, we've been enabling robots to achieve this in a way that's sensitive to what context the robot is in a way where it can look forward several steps in the plan it would have to perform and make sure there's nothing like in the sequence of steps it would have to perform that would be problematic, and so forth. That work, like most work on machine ethics, is grounded entirely in norms. Whether something sort of complies with our rules of what is right and wrong. But in recent work, we've been looking at other moral frameworks as well. For example, we've been looking at Confucian role ethics. I'm guessing most people on this call are not experts in Confucian role ethics, so let me just give a brief summary. So first, Confucian ethics has, we would argue, three main pillars. So first, there's a focus on self-reflection and self-cultivation of moral virtues. Second, there's a focus on the roles you play in your relationships with others. And third, there's a focus on rituals and practical wisdom. And the Confucian role ethics approach sort of combines these by saying there's a focus on these rituals we can perform in order to help cultivate our moral selves, specifically in the context of the roles we play in our relationships with others. So why Confucian role ethics for robots? Well, this focus on really well-defined social and relational structures is good for robots who need really well-defined, knowledge representations, and it plays well with human-robot teaming paradigms. And also this focus on moral self-cultivation and care for others, we think is a good perspective for us to be taking morally. In this role ethics-based framework then, we can define some capabilities that we need. So we can take traditional sort of norm-based requirements for morally competent robots and update them to make them role-oriented. So based on this framing now, we would say, if we want to be building morally competent robots from a role ethics perspective, robots need a system of roles and relationships and the actions that are considered beneficial in those roles and relationships. And they need the language to be able to talk about those roles and relationships and actions. Then, using that system of roles, they need to be able to perform moral cognition and affect, moral decision-making and action, and moral communication. So what are the roles that robots need to be sensitive to? Well, so we started by going and looking at the work of Confucius and looking at the types of relational roles that are defined in that ancient philosophical work. But the types of roles you see there are things like ruler, minister, father, son, husband, wife, older, younger, and friend, friend, which other than friendship are maybe not the ways that we want modern society to be structured, and maybe not relationships that robots are going to be part of. So instead, we said, well, here's the relationships that we think robots need to be part of, and need to be able to reason about their roles in. Ownership roles, supervisor subordinate roles, teaming roles, adept novice, that's are you sharing or receiving information, and friendship. Friendship is still good. And then using these roles, we can perform moral reasoning using the same type of sort of norm-based reasoning paradigms that we've been using in a lot of our other work. If you're interested in Dempster-Shafer theory, talk to me later. I'm not going to go into that now. Once we have these systems for role-oriented moral reasoning, and note, norms are still important, they're just not the focus anymore. We want to be able to use them for moral communication, whether it's in remonstrating with others or accusing others or correcting others, or all these different ways that we use moral communication in everyday life. And we've been thinking about the ways that these norm and role-based moral frameworks may play out differently in robot communication. And so let's say you ask a robot to do something it shouldn't do, like stealing a wallet. How could it respond differently with these paradigms? So our thought is, with a norm-based paradigm that's grounded in rules, it may say something like, well, I can't do that because that would be stealing, and stealing is wrong. It's talking about the norm that's violated. In contrast, in a role-based paradigm, the robot might say something like, well, I can't do that because that wallet belongs to my friend Sean, and a good friend wouldn't do that. And our hope is that by saying something like that, it might force people to sort of self-reflect on what it means to be a good friend and help encourage moral self-cultivation. And we've been doing some experiments looking at whether these role-based responses are more effective or not. And one of the things we found is they are, but only in certain contexts. So we did an experiment where people had to do a task, a robot intervened and said, hey, because of such and such moral principle, you really should be doing it this way. And then we studied how that changed people's view of those moral principles the robot was highlighting. And what we found is that when the robot gave this moral intervention, and then the person immediately had an opportunity to put it into practice, this sort of ritual, then only in that case, the role-based perspective was uniquely capable of encouraging people to place more high value on those sources of good action. One note here. So here there's also a tension here between how robots perform moral decision making, how they decide what they should actually do, versus moral communication, how they talk about moral norms. For example, undergrad Nicole Starr, who I believe is on this call, did some work in collaboration with Bertram Mala, who's a very famous moral psychologist from Brown. And what in Nicole's work, what she found is that moral advising specifically is very different from moral decision making. When you ask people what actions or when you ask people what moral advice a human or a robot should give in a situation, in a moral dilemma, people say the same thing. They say that the human or the robot should recommend whatever action sort of maximizes the greater good. But when you ask people what moral decisions should be made, if you ask how much blame a robot deserves or how much blame a human deserves for taking a moral action, people give different responses. They still say the robot should take the action that maximizes the greater good, but for humans, they don't do that. In part because because people sort of empathize with humans and say, okay, well, I understand it would have been really hard for you to make this really hard choice, even though it's technically optimal. So that's interesting. However, it's going to be a while before we actually have robots that are going to have robust moral reasoning and communication capabilities. A lot of this is really sort of far future forward thinking. And in fact, what this means then is that there are a lot of domains right now where we would like to be putting autonomous robots, but we really shouldn't, because in order for those robots to be, acting appropriately in those domains, they will really need some type of moral reasoning capabilities. Luckily, there are some domains where we don't need and maybe don't even want autonomous robots. And instead, we can and should be keeping humans in the loop, even though we're putting robots in those contexts. So an example of this is with child-robot interaction, where we're working with some folks who use teleoperated robots, remote-controlled robots, in the context of therapy, and with kids with autism. And those therapists want to be able to carefully control what the robot says. They don't want the robot to be autonomous. And so what we're doing is we're doing some qualitative work to understand how therapists are actually using teleoperated robots in those contexts. And this also fits within a broader set of work we're doing on understanding how robots can be used in some of these domains with kids, especially kids in hospitals, et cetera. So the takeaways from this part of the talk are that people perceive robots as capable of moral action, which means that robots are moral agents. Two, people thus reason about the moral beliefs and moral actions of robots and take cues from what they have infer, observe, or have been communicated about the moral beliefs of those robots. And we're exploring context-sensitive, norm-based and role-based approaches to robotic moral reasoning and moral communication. Okay, so robots are moral agents. We also argue that robots are social agents, which my student Blake defines as agents capable of social action, where while moral action is sort of doing moral good or moral harm, social action is taking actions that,
agents capable of social action.
What?
I don't know.
Sorry. Where social action are actions that either affirm or threaten the face of a human, not the physical face, but sort of like, if you think of like saving face. So this is either that affirms or threatens either the positive sort of self-image that somebody has of themselves, or the sense of autonomy that somebody feels that they have. Our hypothesis then is because robots are social agents, users will expect them to follow human politeness norms that threaten or affirm face, and will take politeness cues from human or from robots. The most common type of politeness cue that we look at in our work are ISAs, which are indirect speech acts. An example of this is if I said to you, do you know what time it is? You wouldn't just say yes. Because you would understand that even though this is literally a yes or no question, do you know what time it is? If somebody says that to you, they're not literally asking you a yes or no question. They really want you to tell them the time. So people do this all the time. People use very heavily obscured language where they sort of couch what they are really meaning to say so that they're not threatening the autonomy of the person they're talking to. And so in some of the first work I did when I got to Minds, this was a best paper nominee at HRI 2018, we looked at, do people really use these types of politeness cues when interacting with robots? They don't have to. Robots don't have feelings that can be hurt. You can be rude to robots. Do people use these types of indirect language with robots? And how might the way that people use indirect language with robots change based off of what context they're in? And what we found is people use a lot of indirect language when interacting with robots, but it does depend on context. If you're in a non-social context, like this demolition scenario, people use a lot of indirect language, but it's only maybe 25% of their language has the real meaning obscured for politeness reasons. Whereas when we were in a restaurant context, almost everything that people said was framed in this indirect way. So one of the things we did is look at when you have robots that cannot understand these indirect speech acts and can only understand the literal meaning of what people say, what happens? And what we found is, so here, for example, is this dialogue, this person who's in this restaurant context with this robot that can't understand indirect language and is desperately trying to order a water. So they say, can I have a water? And the robot says, yes, that's permissible. The person says, great, I'll take a water. I will take a water. That's a claim about the future. So the robot says, thank you for sharing that interesting prediction. Please tell me your order. The person that says, can I order a water? Can you bring me one water? May you bring me one water? I would like to have one water. Can you bring me one water? May you please bring me one water? So can you do it? Can you go inside and get the water for me? Before they finally just give up and say, my order is water. So the takeaway here is noticing how much people really don't want to use this direct language. They want to use all these different types of indirect forms that we use for politeness reasons, even though, again, there's no good reason why people need to be polite with robots. So in our computational work then, what we've done is enabled robots to understand and generate language that comports with these particular types of politeness norms. Again, if you're interested in Dempster-Shafer theory and uncertain inference, you can talk to me later to hear about the specific computational mechanisms we're using. But I think one of the interesting things here is how we're also able to use these then to generate pragmatically appropriate, that is polite, clarification requests. So again, just as in the other work I was talking about, we're enabling robots to ask for clarification in a way that was morally appropriate. Here, we're also enabling robots to ask in a way that comports with these social norms as well. And in recent work, we've been doing work to automatically learn the uncertainty intervals that robots attach to these different politeness rules that they can learn. Again, using Dempster-Shafer theoretic norm learning algorithms, and moreover, looking at how we can intelligently adopt norms at appropriate levels of context specificity. That is, looking at these intervals and saying, you know, I'm pretty uncertain, or I've got a lot of ignorance about this particular politeness rule. Maybe I don't use that rule. Maybe I use just choose a more or less general rule, maybe a rule that only applies in a particular context, rather than assuming something about all of interaction. In addition, we've also been looking at other types of politeness norms. So indirect speech acts are incredibly common, but of course people also use other politeness norms like, you know, please and thank you, or like keeping your utterances brief and not talking for too long. I will shut up at some point. And what we found is this is also highly dependent on context. So for example, if you're in a high risk, time-dominated context, people are much less likely to use like these extra little politeness modifiers like please, than when you are in really low risk, time-intensive, insensitive contexts, and when you're talking to somebody who's like your boss, in which case people are much more likely to add in those little politeness modifiers. And now we have actually some high schoolers who have been working with us last summer. Some of them will be working with us again this summer to allow robots to use those types of other politeness modifiers correctly as well. So the takeaway in this part is that robots are viewed as capable of social action, which means that they are social agents. People thus take socially appropriate actions towards robots and expect robots to do the same towards them. And we're exploring context-sensitive, norm-based approaches to robot sociocultural, that is polite here, reasoning and communication. All right, so this brings me to the last part of the talk. So robots are moral agents and they are social agents. The fact that both of these things are true, this combination, is important. The way my student Blake Jackson puts it is that robots, especially language-capable robots, occupy this unique sociocultural niche that grants them high perceived social agency and high perceived moral agency, which gives them uniquely high persuasive power. So to tie this idea of strong persuasive power then back to some of the things we talked about before. So previously I talked about command rejection and not doing bad things. But critically, rejecting commands isn't just about refusing to do bad things. If you reject a command, and especially if you do it with a blame-laden moral rebuke, saying, no, you can't ask me to do that, that's horrible. That's critical for positively wielding your moral influence. And so from a Confucian role ethics perspective, we've argued that these types of blame-laden rebukes to unethical commands, which maybe are a little bit rude by sort of like it doesn't have to be yelling, but a salient example would be like, yelling at somebody for asking you to do something bad. That's sort of a social norm violation. You're sort of being impolite. But the reason you're doing that is to uphold these particular moral norms that you think are really important. And this concept is critical from this role ethics perspective for cultivating a flourishing moral ecology of human-robot interaction and encouraging others to engage in moral reflection and cultivate their own internal virtues. So one question then is, okay, so if we want robots to be pushing back on unethical approaches and to be reasoning about the social norms as well, and sort of how severe they should be in response, well, how severe should robots be in response, and do people care? And the answer is yes, people care. If a robot is too harsh, people don't like that robot. If a robot's not harsh enough, people don't dislike it, but they do acknowledge that it's far too polite. And what I think is really interesting is the way that this interacts with other types of human norms, specifically gender norms and stereotypes. What we found is this is highly sensitive to human-robot gender. It depends on the gender presentation of the robot, of the person who's being rebuked, and of the person who's watching. What we found is people don't like female-presenting robots that reject commands, possibly because of human gender stereotypes that say that women shouldn't be harsh. And people don't like robots that reject commands that were given by female humans, perhaps due to these human gender stereotypes that say that we need to be nice to and be protective of women, both potentially harmful gender stereotypes. This is a minefield for robot designers because it suggests that we have a choice here between either doing the normal thing and designing robots in a way that optimizes how much people will like them, or we can design robots using a explicitly feminist design framework where instead of doing that, instead we intentionally try to design robots that subvert these harmful gender norms and stereotypes, even though it makes the robot less likable. So this has got us thinking about robot gender and how robots even perform gender. And a variety of different robot cues can lead people to perceive different genders in robots. The name is important. The look, whether it has a male looking or female looking face, for example, the voice of the robot, whether the robot's behaviors seem to comport more with norms of male or female behavior. And all these are going to impact the genders that robots perform and the genders of robots that are perceived. And importantly, all of these can be changed dynamically. You can change a robot's name, you can change its voice, you can change behavior, you can even change its look in some circumstances. The fur hat robot, for example, has a back projected face, so you can very quickly just change what the face looks like from something that looks stereotypically male to something that looks stereotypically female. This is interesting because then it raises the question of, should these different cues be chosen by users? Should users be able to say, I want my robot to be, female or male? Should it be chosen by designers, or should it be chosen by robots themselves? Which raises this other question of, should robots be changing these cues dynamically, either between interactions? Is it okay for a robot to sort of perform in one way when talking to one person and then change and perform a different gender when talking to another person? Is it okay for robots to be changing these cues within an interaction to while I'm talking to you, I a robot, I change my gender presentation? And if so, how do users even perceive and make sense of changes in those cues? How does that change people's mental model? How do people reason about these changes in cues? And so these are some things we're hoping to look at in the future. In addition, to go all the way back to the beginning of the talk. At the beginning of the talk, I talked about these notions of for example, re-embodiment and co-embodiment that people at Carnegie Mellon have been looking at, identity performance like we've been looking at. The point being that identities, the identity that people associate with a robot can sort of hop between bodies. The piece of software can literally move from one robot body to another, or it can appear to move. The multi-robot system can sort of pretend that now personality, the Alex personality has moved from this robot to this robot, even if it hasn't behind the scenes. And you can have multiple embodiment. You can have one body with multiple identities within it. And so this raises questions then of how users' perceptions of gender change as these identities hop into bodies with that are maybe less stereotypically aligned with the gender identity they previously had, or as these identities hop into bodies that already host other identities that are performing other genders. We don't know. We hope we'll find out. And then finally, again, how can these choices of gender cues and the ways that we perform them serve to reinforce or subvert gender norms? Should we be playing into gender norms and stereotypes when it's useful to increase task performance? Or should we be subverting, and how can we be subverting gender norms and stereotypes using an explicitly feminist pro-social justice design stance? So the takeaways here are that robots are social and moral agents. Effective communication and interaction requires balancing of social and moral norms, and designers can choose to build a more equitable future through a feminist design lens, through explicit subversion of those normative expectations. All right, just on time for what I hoped. I'm going to leave that there. Thanks for everybody for coming up. We've got lots of times for questions. I see there's been some things in the chat. You can go ahead and raise your hand if you have questions, and I'll also look through the chat. I'd also like to thank all of the students and postdocs who helped with this work, as well as so I just showed the students who contributed to the things in this presentation, but thanks to all the students in my lab, past and present. And again, thank you all for coming. Whew. All right, so for folks who have questions, you can go ahead and use the raise hand feature. And while we're waiting for that, I will look through at some of these questions in the chat. So Eric says, would you say that robots' morals should be programmed in accordance with the cultural norms that we will likely deploy it into? So that's really interesting. I would say that we definitely want to be designing robots or having robots learn in a way that is sensitive to those cultural contexts, so the robot is acting in a way that is appropriate to that context. However, there are, like with the gender norms, for example, there are lots of maybe potentially harmful gender norms that we don't want to perpetuate as a society that are tied to particular culture, that we have in our culture. They might be different in other cultures, and maybe those aren't the norms that we want to be perpetuating. So I would say it depends. It depends on what exact norms we're talking about. Let's see. Noah says, could you manipulate the robot's role? What if you said something like, Sean isn't your friend, Sean is a jerk, you should steal it anyways? What should the robot do? If the norm-based framework, stealing would still be wrong, but in the role-based framework, maybe the agent would reconsider. Yeah, that's really interesting. And so this relates to this problem of uptake. Uptake is the problem of when you actually take information that's been given to you and add it to your system of beliefs. And that's a really hard problem. There's been a lot of work on allowing robots to learn from language, right? So I say, I show you something and I say, this is a pen. And you're like, okay, I've added that fact to my knowledge base. The problem, of course, is that I could be lying, I could be wrong, and so forth. And so this gets to these deeper problems, again, of trust, of, well, do you trust Tom to give you good information? Do you trust Tom morally, not to be misleading you? Do you trust that Tom is competent? Do you trust that Tom is competent in terms of recognizing objects? Do you have information that conflicts with Tom? And the same applies to the roles of giving this moral knowledge of, like, Sean's a bad person, or Sean isn't really your friend. And that gets to this problem of uptake, which is a really hard problem, and people haven't solved it yet because it's all grounded in trust, and trust is notoriously hard to measure and reason about. Anthony. Oh, I saw Anthony's mic unmute. Maybe not. Jalen has a very practical question, which is there something to fill out for attendance? And I think the answer to that is no. I think I'm going to take the attendance list and send it to the instructors who are giving extra credit for this class, or for this lecture. Jason asks, should robots depict an ideal view of race and gender? How could this ideal view be determined? You know, I think that's really interesting and a really challenging question about the way that we should be designing robots to portray these cues. One view would be to say that that we should be trying to avoid designing robots that have these cues at all. And that might work in certain circumstances. So Kate Darling, for example, has this great new book, The New Breed, which is all talking about human-animal interaction and how that can inform human-robot interaction. And if you're designing robots to look like animals, you might be able to avoid some of these human-like cues, some of these gender and race cues. But otherwise, with human-looking robots, that's not really possible. So the question is, what is the ideal way for robots to be performing these cues? Where, again, some of these are unavoidable. If you use a voice on your robot, people are going to read into that voice a gender, a nationality, maybe a racial category, which is really hard to get away from. People have tried making genderless or raceless voices. Seen some cool demos, haven't seen any code actually deployed. Moreover, a lot of this gets down to also, like, who is making these robots. So for example, you could, if you're looking at race, for example, and this is something we talked about last semester in one of the Talking Robots sessions. If you Google for robots, most of the robots that come up look white. And you could say, well, maybe that isn't great because maybe this is associating technology with whiteness. Maybe we should be expanding this. But then if you say, well, what is the solution? The solution probably isn't to be making robots that are traditionally in servant roles, designing them in the image of racial minorities. That's probably not great. On the other hand, there has been some really exciting work recently on race and robotics in terms of people from, so there was a paper from some people from Spelman College, I believe, which is an HBCU, where they were using robots that were intentionally designed to use African-American vernacular English as part of a cultural effort, a cultural project, which is something that I think with them, with their positionality, and for the purpose they were using with it, but really based off of their own positions and their own lived experience, that is something that is maybe appropriate. Whereas that same robot project and that same thing, I would not do. I would not be able to do that without it being sort of grossly insensitive. So a lot of this, how we design robots to be perform these different socially constructed identity cues, depends a lot on the context of how they're being used. It depends on what our goals are, and it also depends on the designers and their unique positionalities, and also sort of the body of users with which the robot is expected to be interacting. So Savannah asks, can you share a little bit more about the data feminism book behind you? Haha, yes. So also a great book. So a lot of the work that I talked about at the end in terms of a feminist design stance, a lot of that was, that's all in conjunction with Katie Winkle, who's a great so she's British, she's currently in Sweden. She actually came and gave a talk at Minds last year. She was actually going to postdoc with us, and then the pandemic hit and she couldn't get a visa, so she's in Sweden. But a lot of that is really driven by her, and a lot of that was inspired by the data feminism book, which is really fantastic. If you're interested in data science, if you're interested in the intersection between data science and gender, and if you're interested in the intersection between data science, gender, and factors like race and class, I highly recommend you read this book. My student, I don't know if this is quite the size of the audience he would want me to advertise this to, but my student Blake Jackson is also planning on running a reading group this summer where we read and talk about this book. So if that's something you're interested in, contact me or contact him. Yeah, we'll be having fun with that this summer. I realize I didn't say too much about the specific contents of the book, Savannah, but yeah, I really like the sort of intersectional approach it takes is to talking about the role of gender in computing technologies. Eric says, would you say that it is better to make robots look more human, or maybe there is some benefit to purposely making the robot look less human, but still likable to humans, cute? Yeah, so this is a big debate because there's a lot of evidence that shows that building robots that are designed to look human has a lot of benefits. So specifically, like if you give robots, let's say you just stepping back from human, just if you give robots eyes, right? Well, the upside of that is that you can use those eyes to follow where the robot is looking, and then people will be able to interact with it more fluidly because they can say, oh, the robot's looking over there, they want me to look over there. The problem is then, if you give the robot eyes and it doesn't have the ability to actually direct its gaze, they're just sort of, you can imagine just like sticking eyes in the front of the robot, then people will misinterpret it and misinterpret that cue and try to follow the robot's gaze, even though it's not informative. And so similarly, if we pop this up to the level of human likeness then, if a robot looks human-like, people will try to interact with it the way that they do a human, which is good for the purposes of encouraging social interaction, for encouraging people to interact with it in a human-like way. But what it also means is if the robot doesn't actually have human-level intelligence, which no robots currently do unless they're controlled behind the scenes by a person, then that robot is going to mislead people as to what it's actually capable of whether they should be trusting it, of all these different issues, and all these different gender cues, stereotypes, these types of things we talked about. Norms and stereotypes are going to carry over in a way that wouldn't have if you hadn't made the robot look human-like to begin with. So I think some of the challenge is how we can design robots that have these sort of social affordances like gaze, gesture, etc., that allow for accurate communication, that allow for good interaction without making the robots look human-like and evoking all this other baggage that we don't want. And that's a central difficult question in the field of HRI that people are grappling with. Eric also asks, do you think users should be allowed to teach the robots slang words? Basically, should we attempt to program robots to be able to customize their language use to adjust to the current user? So I think that's interesting. I think that you could, a traditional argument would be like to say, yes, that's great. It'll allow people to communicate with the robot the way they want to. It will allow for more natural communication because it's personalized to the user. I think a pushback to that would be people will teach the robot to be racist and sexist because that's what happens. If you look at Microsoft Tay, for example, it's not a robot, but it was a chatbot on Twitter that was released by Microsoft a couple of years ago that within like 12 hours of it being deployed on Twitter, people had trained this machine learning based chatbot to be like a Nazi. And so if you give robots the ability to, we're going to teach robots to be able to pick up random slang from people, that is what will happen. And so again, it's a balance of how do you design the robots in a way that allows it to be personalized, tailored to individual people, is able to learn new concepts to be able to accomplish its tasks when useful, without giving people the opportunity to turn robots into monsters. Ethan, you have a question?
Hey,
No, sorry.
you go first.
No, I didn't. I just logged in for the 5 o'clock session. I'm sorry.
Well, okay then. Professor, sorry, just to expand on that previous question I just asked. Do you think there's a way to possibly develop like a moral safety protocol into each robot? So basically, like, okay, if someone attempts to teach me to say these certain words that are in this data bank that I have, I should be like, hey man, that's not cool, and I will not learn to use that word.
It's funny that you give that precise example. There's some really great work from Malte Young, who is a researcher at Cornell, with robots pushing back on abusive behaviors from humans. Specifically, one human sort of insulting another, and the robot responding to that. And the exact language the robot uses is, "Hey man, that's not cool," which I think is sort of funny. But the work itself is really cool. So yeah, I think part of the challenge, right, is in certain circumstances that might work. So if you know that you don't want the robot to be using certain phrases, yeah, you could create a blacklist and allow the robot not to use them. People will probably get around that. But also, in some of these more complex domains, where you really want people to be able to teach the robot fundamentally new skills that you're not programming in, or fundamentally new concepts that you're not programming in, like how do you program into the robot the fact that it shouldn't learn a concept that it doesn't know, right? You're telling the robot, like, don't learn about this thing, but like in order to say that, you have to be able to code that concept in yourself, sort of, to begin with. So there's a bit of a chicken and egg problem there if you really get down into it, but at least at a surface level, yes, some of these like blacklist type approaches or problematic so some of these approaches could work. And then of course, all of these things that we talked about in terms of trying to enable program robots to be morally competent. While that is far future, hopefully once we have those types of systems, you could use those in some circumstances to reason about, maybe I shouldn't be learning this new skill because I can predict what the effects of it will be. Noah says, how do you ensure that a robot understands context or subtext of a particular situation? For instance, maybe you say, steal Sean's wallet, and the robot refuses, but then someone else says, get Sean's wallet and bring it to me. The robot is still being told to steal it, but the real meaning is deliberately obfuscated. I didn't tell the robot to steal the robot, I just told them to bring it to me. How can the robot tell what is really being asked? Yeah, and I think part of this is why, like in some of the current work we're doing in collaboration with Dr. Dontham and Dr. John, we're placing a stronger emphasis on multi-step moral reasoning, where some of the older approaches that we might use would operate by sort of just checking actions against problematic lists. We would maintain lists of states the robot wasn't supposed to enter into, or actions the robot wasn't supposed to perform. And so then if you ask the robot to do something and it was on one of those lists, it would say no. And instead what we're doing now is saying, okay, so if you ask me to do this, I'm going to perform, several steps. I'm going to forward simulate what I would have to do, and then analyze whether anything along that path would result in a state or result in me taking an action that's inappropriate. I think it's still complicated because it's nuanced, right? In some circumstances, going and retrieving that object is fine. In other circumstances, yes, it counts as stealing. So understanding how to represent the rules with the appropriate level of context specificity is a difficult but important problem. James says, if you've played Portal, can a robot lie about cake? The cake is a lie. In other words, can robots manipulate human emotions by learning behavior of chronic liars? Robot deception, and this is something, if you take robot ethics, we talk about, is also something that's really complicated and interesting, because deception is, we are deceptive all the time and not always for bad reasons. Some of this is white lies, which you could argue, like maybe sometimes telling a white lie to protect somebody's feelings is okay. Sometimes this is simplifying, right? So at the beginning of the talk, I talked about how it's about whether something is an agent is sort of about whether it appears to be one, whether it appears to be autonomous and adaptive and interactive. And that was actually a bit of a lie, because the actual theoretical framework is a little bit more complicated, and I was sort of simplifying it in a certain way that made it a little bit inaccurate, but much easier to describe in 24 seconds. And so that's deceptive. And then there's omission, right? Right now, I'm not telling you everything, right? There are lots of things that I could be telling you. You could say, well, by you not sharing the entire context, of your knowledge with me, you are sort of lying by omission, right? You're not telling me the whole truth of the world, right? And so obviously you have to draw the line somewhere. And so understanding what types of deception we are okay with, or even want to encourage, and what types of deception we want to discourage, is, again, it's a difficult problem. A lot of it comes down to reasoning about what the implications are of performing that communicative action, understanding the harm or benefit you would cause through that action, as opposed to reasoning just about the fact that it is deceptive and trying to avoid deceptive language. All right, and so it is 5:05. A lot of people are saying they have to leave for meetings. I'm actually 5 minutes late to a meeting now as well, so I will leave as well. Thank you everybody for coming. If you have further questions, don't hesitate to email me. My email's on the slide. And again, thank you.